Transformations of piecewise functions work the same as all of your graphing transformations from Algebra 2, Algebra 1. A couple things to keep in mind there is that the A value is vertical and the K value is also vertical. B and H are horizontal. Remember that horizontal shifts and stretches are always counterintuitive, so they're a little opposite of what you might think. So how do we do this, or how do we apply this to piecewise functions? First, let's take a look at the piecewise function that we graphed in last night's video. So what we're going to do here is take this function from last night and we're going to graph a shift of it. And what shift are we going to graph? Well, we have f of x defined from last night. We're talking about a new function called h of x. And what is the definition of h of x? Well, it's f, and it's been moved this way and this way. So we have to interpret what those transformations are. The -2, remember, counterintuitive, would be right 2. And the -5 is vertical, but that's what you see, so down 5. And this is no more difficult than taking what you have in your original graph and just moving it to those directions. So we take each point and we simply shift it by what this tells us. So if I go right 2 for the parabola, down 5, and all the points, right 2, down 5. Okay, right 2. Okay, that gives us the shifted parabola. And the shifted line, and that will be transforming a piecewise function. So the same as transform our others, the gaps appear the same, the domains, the domain shifts, all right, because we moved it right 2. We'll talk about that in the next example. Moving on. So here is, again, a function from last night's video. So we're going to take a look at what happens when we shift this function as well. So there's our graph from last night. Again, we're applying these shifts. Now +1 inside the parentheses is going to be left 1, and +2 outside is going to be up 2. All right, just remember that horizontal shift there is counterintuitive, and these shifts apply to all the functions, right? So it doesn't really matter what order I go in, but if I take my horizontal line here, I move it to the left 1 and up 2. All right, then it's going to end up being here. Okay, and then I take my parabola, I move all my points left 1 and up 2. And I end up with my new parabola. Section, at least, sub function, and then left 1 up 2 here. Now the nice excuse me, the nice thing here is that this line actually ends up being the same as the line before it. Okay, because it's still having a slope of 2. So that will be shifting that piecewise function. And finally, the last piece of this will be, okay, well, once we shift those functions, how do we then write their new equations? And here's where function composition comes in from Unit 0. This is why you needed to know function composition. Because what I'm actually going to do is take these shifts and I'm going to substitute them into the original functions. If it's in parentheses, the shift, then it needs to go in parentheses for the x. If it's not in parentheses, then it can go outside of the function for the x. So h of x here is going to equal, and I'm going to copy down my original function. But instead of an x, I'm going to use empty parentheses. Okay, and then in those empty parentheses are where any of my horizontal movement goes. So x minus 2 goes in the parentheses. The -5 is vertical, it could go outside, and so -5. All right, and then the second equation here, again, I'm going to copy it down, but I'm going to leave empty parentheses where the x is. Again, that was the tip that we used during function composition. All right, and then inside of those parentheses would be any horizontal shift. Outside would be any vertical shift. Now, I would never want to leave that as my answer. I would want to simplify, that function, so that way I don't have, like terms inside here, like terms outside here, right? So if I do that, I would end up with x minus 1 squared minus 7. Okay, and then here I could distribute to 3 if I wanted to. You don't really have to. All right, but the positive 1 and negative 5 make negative 4. When I distribute to 3, I end up with a negative 6 and negative 4. So I get 3x minus 10, I believe, for that second equation. And now I need to adjust my domain. So there's two ways to adjust the domain. You can either go back and reference your graph and say, okay, well here my domain, you know, in this first graph, my domain here was split at the x value of 1. The only shift that's going to affect my domain would be the right shift. So if I look at this second graph, my domain now jumps at 3. So that would be one way to go back and readjust your domain. The other way would be to say, okay, well, my horizontal shift to the right 2, so plus 2, and plus 2 gives me the 3 for my domain change. So here x would have to be less than or equal to 3, or x would have to be greater than 3. All right, a little trickier here for the second one. All right, you know, the only thing that's going to change a y number, because there's no x's here, so I'm not going to ever have the opportunity to substitute the x plus 1. So the only thing that's going to change that y number would be the plus 2. So 5 plus 2 is 7. That takes care of that one. Second equation here, again, in place of the x, okay, I'm going to write x plus 1. Horizontal goes in parentheses. It goes in place of the variable inside the function. The vertical shift plus 2 goes outside. And last, same idea, okay. Inside those parentheses will be my horizontal shift, x plus 1. Outside the parentheses will be, whoops. Outside the parentheses, it does say plus 4 to start. I'm going to plus 2 more. All right, and just like we talked about in the previous problem, we would want to simplify this. You know, again, it can be as much as you want. Here, the minus 4 and the plus 2 are going to give us a minus 2. And here, the plus 4 and the plus 2 are going to give us plus 6. And I'm just going to let the parentheses alone this time. Nothing wrong with that. And last is my domain. Again, the domain is only changed by the horizontal shift. So I know that says plus 1. Okay, so if you were doing this by letter of the law, we would replace all of our x's with an x plus 1. So let's just take a look at what that looks like. If I had x plus 1 less than or equal to negative 3, and I had to resolve for x, I would be subtracting 1 from both sides. That's the left movement that my horizontal shift gave me. All right, so that would be x is less than or equal to negative 4. X is less than or equal to negative 4. If I replace this x with an x plus 1, all right, I'm going to go up here. I have negative 3, x plus 1, and 2. The only way to get x back by itself would be to minus 1 from everything. All right, so again, you see here's another way to acquire that new domain besides using the graph. And then finally, x plus 1 is greater than 2, and then that means x is greater than 1.